Today we shall discuss about lanthanoids and actinoids, their comparison. The electronic configuration of lanthanoids is given by xenon 4f1 to 14, 5d0 or 1, 6s2. Whereas in actinides it is radon 5f1 to 14, 6d0 or 1, 7s2. Coming to the oxidation states, you find that lanthanoids are having the common oxidation state +3, which is true for actinoids too. The other oxidation states exhibited by the elements are +2 and +4, whereas in actinoids it will be +4, +5 and even +6. Coming to the sizes of the atoms or the ions, as we move along the lanthanoids, due to lanthanide contraction, the size keeps on decreasing across a period. Same is the case with actinoids. There, actinoid contraction occurs and the size decreases when we are moving from left to right. Coming to the chemical reactivity of lanthanides, you find that lanthanides are having less tendency to form complexes. Except for promethium, all other lanthanoids are non-radioactive in nature. But when we are comparing the properties of actinoids, you find that they have more tendency to form complexes and all the actinoids are radioactive in nature. The next property that we find in lanthanoids is that they do not form oxocations, whereas actinoids, they form oxocations. Some of the examples are UO2 2+, PuO2 2+, and UO2 plus. When we compare the basic nature of the oxides and hydroxides, you find that oxides and hydroxides of lanthanides are less basic compared to that of actinoids. So with this, we have briefed all the differences between lanthanoids and actinoids. Coming to the next one, that is some more properties of D block. We are going to learn what are the different types of oxides and halides formed from 3D series. Take the first case, scandium. Scandium will show +3 oxidation state, due to which it can form the oxide of the type SCO with +3 and -2. So the formula is SC2O3. Hope it is clear. Likewise, titanium will show a variety of oxidation states starting from +2 to +4, which will give rise to TiO, Ti2O3 and TiO2. Here, oxidation state of titanium will be +2 because oxygen is -2. Here it is -2, so this becomes +3. This is having +4 as the oxidation state. Hope it is clear. Now coming to vanadium. Vanadium forms a variety of oxides where it can exhibit +2 to +5. So you find the different oxides will be of the type VO, V2O3, V2O4 and V2O5. Check the oxidation state. This one will be +2. This is +3. Next one is +4. And the last one is +5. Hope it is clear. Now coming to chromium. Chromium shows a variety of oxidation states starting from +2 to +6. Different compounds formed are CrO, Cr2O3, CrO2 and finally CrO3. So oxidation state will be +2, +3, +4 and +6. Coming to the next one, Manganese. Manganese shows a variety of oxidation states starting from +2 to +7. So we have a variety of oxides MnO, Mn2O3, MnO2, Mn3O4, that is a mixed oxide, and finally you have Mn2O7. Likewise, you find the compound formed from iron will be FeO, Fe3O4, and finally Fe2O3. Likewise, cobalt forms only two oxides of the type COO and CO3O4. Coming to nickel, nickel is found to form only one oxide NiO, whereas copper will form CuO and Cu2O, and zinc oxide forms ZnO. Hope it is clear. You can just calculate the oxidation state of the different transition metals from the series. Now, on examining the different oxides, you find that the one which is having the highest oxidation state is found to have covalent character. This is according to Fajan's rule, and due to which you find the oxides that are formed which are covalent in nature is found to be more acidic. So when we are just checking the case with manganese, manganese forms a variety of oxides. Here you find that it shows oxidation state ranging from +2, +3, then it is showing +4, and this is showing +4, and this is showing +7. So in all the cases you find that as the oxidation state is found to increase, the covalent character increases, that is basic nature of the oxides are found to increase. Coming to the halides, you find a variety of halides are formed from these compounds starting from titanium. Titanium can form TiX4, TiX3 and TiX2. Coming to chromium, you find that chromium can form CrX2, CrX3. It can also form CrX4. In addition to that, it can form CrF5 and CrF6. This is the highest halide that is formed from chromium. Coming to manganese, you find that manganese will have the oxidation state MnX2, that is +4, MnF3 and MnF4. So likewise you find that for different oxide, D block elements, you can get a variety of halides FeX2, FeX3. Cobalt will form COX2, COX3. Nickel will form NiX2. Copper will form CuX2 and Cux, and zinc will form ZnX2. Hope it is clear. So on comparison, we find that the highest oxidation state is exhibited either in its oxide and halide. When we check the halides, you find that the highest oxidation state is shown by fluorides, and the reason is the fluorides are the most electronegative ions, and due to the small size and high electronegativity of fluorine, it can make the metal get oxidized. Coming to the oxides, you find that oxygen is also a small atom with high electronegativity, so it can oxidize the metal attached to it very easily. In addition to that, oxygen also shows the capacity to form p-pi multiple bonds or double bonds, due to which it shows the highest oxidation state in its oxide. Hope it is clear. So we'll just summarize the points here. Trends in the stability of the highest oxidation state. Highest oxidation states are present in tetrahalides in transition metals. Examples: tetrafluorhalide, TiX4, VF5, CrF6. In addition to that, the highest oxidation state of transition metals are seen in the oxides, example V2O5, Mn2O7. The highest manganese fluoride is MnF4 and that of the oxide is Mn2O7. Another important point that is relevant in D block is that as we move down the group, the highest oxidation state becomes more stable because inert pair effect is absent in D block. Whereas in the main block elements, mainly the P block, as we move down the group, the lower oxidation state becomes more stable because of the reluctance of the ns orbitals to unpair. Inert pair effect is totally absent in D block. These are the main points in D block elements. Hope you have understood. Now try to answer these questions. First question: what are interstitial compounds? Give reasons for the following. First one: lower oxidation state of transition metals is basic, whereas the highest will be either amphoteric or acidic, and transition metals exhibit highest oxidation states in its fluorides or oxides. Give examples for oxoanions in which the transition metals will have the oxidation state equal to the group number.